Now the lazy instantiation. Lazy instantiation means we are just going to create the instance at the time of when it is required. If it is not required, then we will not create the instance. You can see the code here. The class 1 is the class name, instance is the variable, it is private and static. The data type is class 1. We are using the private constructor. We know why we are using the private constructor, because we don't want to be get accessed by the outsider classes. And one method is there, get instance, which is public and static. Public means it is accessible from the outsider classes, and the type and the return type is class 1, so it will return the class 1 instance. And within the get instance method, we are checking whether instance variable is null or not. If it is null, then only the new instance will be created, otherwise the existing instance will return. Now the thing is this, we are seeing instance is not assigned directly under the class 1. It is written in the get instance method, and that is why when the class 1 will be called, the instance will not be generated. It is only generated on requirement. When the get instance method will be called, then only the instance will be created. So now we do not have the issue related to resource and CPU time. Also, we have the option to manage the exception handling. So we have overcome those issues. But till now, we have some disadvantages. What are those? Look, we are using the get instance method, so we do not have the direct access with the instance. One problem. Second is, we have the null checking clause. So whenever the get instance method will be called, the check will be fired. It is another problem. And last problem is that if the environment is multi-threading, means if multi-thread is just want to access this get instance method simultaneously, then the method will not be behave as like singleton, because if multiple thread just going to access this method simultaneously, then multiple object can be generated. So these are the disadvantages is available in using the lazy instantiation. To overcome the multi-threaded related issue, we need to make the get instance method thread safe. So what should we do? We need to use the synchronized keyword, because we know if we use the synchronized keyword, then only one thread will be able to get access at a time. So now what we will do, you can see the code. We have the class 1 class, and the instance is the variable, which is private static, and the private constructor. We know why we are using the private constructor, because we don't want to get access from the outsider classes. And we have the get instance method, which is synchronized. So now one thread will be able to get access at a time. So we are seeing that we overcome the all issues related to thread, related to resource and CPU time, related to null exception handling. But till now we have one issue. Issue is nothing but the performance. Just because of we are using the synchronized keyword, only one thread will be able to access to the get instance method, and it is a problem, because if the environment is for multi-threaded and only one thread will be able to get access to the get instance method, then the application will be slower. So in synchronized keyword is the reason of slower performance. Let's see how we can overcome this situation. The next is lazy initialization with double check locking. What the thing we are doing here? Now you can see the code. Class 1 is the class name, and the instance is the variable whose data type is class 1, same as the previous. And private static, we are using the private constructor. We know why we are using the private constructor, because we don't want to get access from the outsider classes. And the get instance method, oh fine, it is not using the synchronized keyword, and it is checking the instance is null or not. If it is null, then only the synchronized block will be called. And under the synchronized block, we are creating the new instance if the same is not available. If it is available, then we are not calling the synchronized block. We are just return the existing instance. So now we are seeing that we do not have the issues related to resource and CPU time. We do not have the issues related to thread. We do not have the issues related to slow. We do not have the issues related to null exception. But till now we have our disadvantage. What is this? This is nothing but we have the problem of slow performance for the first time, because if the instance is not available, then we are making the particular block as synchronized, and that time only one thread will be able to get access on the particular block. So for the first time, when the instance will be called, instance will be created, the performance will be slower. How I can overcome these issues? To overcome this, I will use the build pug singleton implementation. This is very popular. Most of the developers are using this method, using this form. Before Java 5, there were lot of issues related to memory. There were lot of issues related to thread, and that is why they used this form. You can see the code here. The class name is class1. We are using the private constructor. We have the instance variable which is static and final, and we have the get instance method which is public static. It is same as the eager initialization. Just one difference is there. We are using a inner class and we are initializing the instance variable within the inner class. Now let me describe about the static final. Why we are using the static final? Final makes the instance variable, final makes a variable as constant. Constant means the variable which is already assigned, it is not going to be changed in future. Okay, but we have some problem with the final keyword. The problem is that if any user is using the final keyword, on each call it will allocate a new memory space. But our motto is to allocate only one memory space. So we are using the static keyword. So now we have the static final, and it is private, so it is not going to be accessed by the outsider classes. So let me describe the execution part. So first, when the class 1 will be loaded, instance will not be loaded, because the instance is written under inner class, and inner class is not going to be fired at the time when the class 1 is loading. So it is implementing the lazy instantiation, and whenever the get instance method will be called, only then the instance variable will be called, and only then the new instance will be created. And because of we are using the final keyword, so the instance will be called at the first time, and from the second time the class 1 constructor will not be called and no new instance will be created. Because once the instance variable is assigned with the new object, it will not going to be changed further. That is why if the multiple thread is going to access the instance variable, it will not make any problem. So now we do not have any issues related to resource and CPU time. We are not creating the object at the time of class loading. We have the option of null checking. We have the option of exception handling. We have the option that we can run the code in the multi-threaded environment. we are not using the synchronized keyword, and so our code will not cause of the slower performance. Let me describe one by one. The first is eager instantiation. Here we are creating the object at the time of class loading, and we do not have the option to check the. If our requirement is that the object is required from the first time, and we do not have to check any exception related issues, in that case we should go for the eager initialization, because it is very easy to implement and it is faster. And if we need the exception handling related code, then we need to go for the static block, using the static block. The second one. Now the part is of lazy instantiation. Lazy instantiation means we are not going to create any object if it is not. If our requirement is that our the object is not required from the first time, then only we should go for the lazy instantiation. Now, if our environment is thread safe, then only we should go for the thread safe implementation. If we think that if our used synchronized keyword is just going to be a cause of slower performance, then we should go for the lazy initialization with double check locking, because here we will use the synchronized block only when the instance is not available. And the next will pug, it is the best choice forever. Okay, so this is the all about the singleton. Next class will be on prototype design pattern. So thank you for the day. We'll come tomorrow.